Hello everybody, welcome to Forces Unit 1 Lesson 8. This lesson is about the spring constant and elastic potential energy. For this lesson you will need a pen or a pencil, a piece of paper or a book, something to write on, and probably a calculator to do some of the calculations. If you don't have these things, pause the video and go and get them now. As always, we start this lesson with some questions from previous lessons. All you need to do is write down the answers on a piece of paper, pause the video. When you press play, we'll go through the answers. Let's see how you've got on. What happens if the resultant force acting on an object is 0? The answer is there is no change in speed or direction. Do remember you can have a speed of 0. So if the forces on you are balanced and you are stationary, you stay stationary. What happens if there is a resultant force acting on an object? You get a speed and or a direction change. Scalar quantity, well, that is one where you have magnitude or size only. Something like mass of 56 kilograms or a time of 36 seconds. No direction involved, whereas the vector quantity does have that direction. So a magnitude, so you could have 4 meters per second is the size and direction north. What is the extension in a spring? It's how much longer it is compared to its original unloaded length. So that's the length it is before you add any weight to it. You got those right? Well done. Today we've got a second part to our mini test. A few more questions. Pause the video, write down the answers, and then we'll go through them in a moment. So let's see how you've got on. What is the spring constant? Well, the spring constant tells you how stiff the spring is. The stiffer the spring, the harder it is to stretch or squash, the higher the spring constant. And what is the equation for calculating the spring constant? You'll remember doing this last lesson on the graph. It is either F equals KE, F for force, K for spring constant, E for extension, or K equals F divided by E. You got those right? Well done. Let's recap what we did last lesson then. We collected some data, we plotted our points on a graph, and we were trying to work out the spring constant. We're doing this from our graph by picking a couple of points, working out the difference in force and the difference in extension, plugging those numbers into our equation. K, which is the spring constant, is force, F divided by E, extension. The only little tricky bit we sometimes had in there is we very often had extension in centimeters and we needed to convert it into meters. But that's how we calculated the spring constant. So what happens if you know the spring constant? What sort of questions might you be asked? Well, let's have a look. Here's one. A spring has a spring constant of 10 newtons per meter. How much force is needed to increase its length by 3 meters? Well, what you need to do here is start off with your equation. Force equals spring constant times extension, or F equals KE, and then go through the question and work out what you already know. So that 10 newtons per meter is a spring constant. Forces are unknown, and length, well, extension that increases its length, so that's going to be extension, it's going to be 3 meters. So we know those 3 things, we can plug them into the equation. F for force, because we don't know what the force is. The spring constant we know is 10 times 3, the extension. So we plug those in, multiply that out, and that gives us an answer of 30. Now, as always, the last stage is always to include the unit. It's a force, so it's going to be measured in newtons. That's how you do it. Very simple stages. Equation, work out what you know, substitute, do your calculation, and add your unit at the end. Time for you to have a go at one now. Follow the same method as I did. Pause the video, and then I'll go through what you should have done in a minute, and we'll see how you got on. Pause the video. So this is what you should have done then. You should have started off with the equation, F equals KE, highlighted in the question either the things that you already know or the things that are unknown. So we already know the spring constant. We don't know the force, that's our unknown, and the 6 in there is our extension. Substitute them in. F we leave is F because it's the unknown, 5 the spring constant, 6 for the extension. Calculate that up as 30, and our last step is we add in the unit, and force is measured in newtons. You got that right? Well done. Time for a new key idea now. This is the idea of energy stored in springs. You know that when you stretch a spring, you store the energy. And when you let go of that spring, when you release it, you get that energy that you have stored back. There's a little equation that you can use to calculate the energy stored in springs. The energy that is stored in springs is called elastic potential energy. And elastic potential energy equals a half times the spring constant times the extension squared. You need to record that key idea on your piece of paper. Pause the video, write it down. We can use that equation to have a go at this example question. A spring has a spring constant of 4 newtons per meter. It is stretched 0.6 meters. How much energy is stored? Well, the way you do this problem is you start off with the equation. Elastic potential energy equals a half times the spring constant times the extension squared. Then you go through your actual question and you highlight the things that you know and find your unknown. So we know that the spring constant is 4 newtons per meter. We know it is stretched 0.6 meters, so 0.6 is our extension, and how much energy is stored. So that's what our unknown energy, in this case, elastic potential energy. So we substitute those in. So elastic potential energy we don't know, so we write that out. Half times the spring constant, which is 4, times extension squared. Extension is 0.6, extension squared is 0.6 times 0.6. So that's our substitution. Get your calculator out, plug those numbers in, and you will come out with 0.72. One more step for you to do. Elastic potential energy is a type of energy. We need to add a unit, and the unit for this is joules. Add our unit in, 0.72 joules. One for you to have a go at on your own now. Pause the video, and when you press play again, we'll go through the answer and see how you've done. Well, let's see what you should have done. You should have started off with the equation. You should have gone through the problem and highlighted what you know and find your unknown. So we know the spring constant is 8, the extension is 2.6, and energy is our unknown. Substitute those into your equation. So you can see half times 8 times 2.6 times 2.6. Remember, it is extension squared. The biggest mistake people make on GCSE exams, they forget the squared bit. Use your calculator, that comes out as 27.04. We're going to round that to 27, and we're going to add the unit joules in. You got that right? Well done. Sometimes it's a real pain having to write out all the words, especially if you've got something long like elastic potential energy or spring constant. Lots of words, very difficult to fit it in, so we can use symbols. So this is our equation. How can we use symbols for this? Well, it's quite simple. We use, for elastic potential energy, we use a capital E because it's energy, and a little e to show it's elastic potential energy. That's that one there. Spring constant we've come across before. We know spring constant we use a K for, and extension we use E for. Remember, it's extension squared, so it's E squared there. That equation needs to be recorded down as a key idea on your piece of paper. So pause the video now and write it down. So let's use our symbol equation then to have a go at a problem. Pause the video, write down what you think the answer is, and I'll go through the answer in a moment. Let's see what you should have done. Start off by writing out the equation, and we're doing it in symbols now rather than full words. We're going to go through our question and see what we already know. So we know the maximum stretch is 6 meters. So 6 meters is the extension. At full stretch, the rope acts like a spring with a spring constant of 650 newtons per meter. There's our spring constant. How much elastic potential energy? That's our unknown. So we can substitute those in. The 650, the spring constant. It's 6 times 6 because it's 6 meters times 6 meters because it is extension squared. Work that all out, 11,700. Of course, it's energy, so we need to add our unit, which is joules. You've got that right? Well done. Another question for you to have a go at now. Pause the video, press play when you're ready to go through the answer. Let's see what you should have done. Well, start off with the equation and then go through and highlight the things you know. A spring on a car is compressed by 10 centimeters. Compressed is basically the same as extending it, except obviously it gets shorter rather than longer. So for our extension, we're going to use 10 centimeters. The spring constant is 100,000, so we're going to include that. Elastic potential energy is our unknown. So those are the things that we're going to work with here. Substitute them in. E little e is elastic potential energy, a half times K, that's the 100,000. Now it says 0.1 times 0.1. The reason for that is we can't go 10 by 10 because 10 is measured in centimeters and we know extension should be measured in meters. So we need to convert it, and 10 centimeters is 0.1 meters, and it's 0.1 times 0.1 because it's extension squared. Calculate all that out and it comes out to 500. Now 500 is a type of energy, so its unit is going to be joules. You got that right? Well done. So some final key ideas, this time about spring limits. You'll remember Hooke's law, the idea if you double the force on a spring, you double the extension. It's the bit where the graph is a straight line. So you remember doing something a little bit like this previously, where you can see here, there's a nice straight line. If you double the force, you double the extension. Now, two new ideas, limit of proportionality. Now, proportional means if one doubles, the other doubles. So all of this bit here, well, it's a straight line, is below the limit of proportionality because it still obeys Hooke's law. But if you carried on going on and on and on, and the graph went up a little bit like this, it may start to curve. The point where it is no longer a straight line, it is no longer proportional. So that is what we call the limit of proportionality. And I've pointed to it on the graph, that point there. So the limit of proportionality for this particular one would have been at 11. 11 newtons was its limit of proportionality. Or you could express it, its limit of proportionality is when it got to 70 centimeters long. So that's what we mean by limit of proportionality. It's when the graph actually stops being a straight line. Now, if you've done this experiment in class, you may have found someone in your group would have added a little bit too much force to that spring, and that spring would be permanently stretched. It will not go back to its original length. And that is what's known as the limit of elasticity. So let's say, for example, you can put 20 newtons of force on and it goes back to its original length, but someone puts 21 newtons of force on and it permanently stretches it, then 20 newtons, quite simply, is the limit of elasticity. It's how much it can take before it is permanently damaged. You need to include the limit of proportionality and the limit of elasticity on your piece of paper or in your book as part of your list of key ideas for the lesson. If you want to use the graph to help explain it, if you want to jot down what Hooke's law is because you can't remember that, feel free to include other information if you want. Pause the video. To finish off with today, we've got a little mini test, and this is match the pairs of boxes. Probably the best way for you to do that is to either write out a couple of long sentences as you match them up, or write out the equations. Pause the video and we'll go through the answers in a bit. Okay, let's see what you should have come up with. So check your answers. Here are the correct ones. If you need to pause the video, then pause it just so you can check your answers. But if you got them all right, well done. That's almost it for this unit. Finally, anything you didn't understand in this unit, there's a few things you can do. You can replay the videos. They're not going to be deleted. You can watch them whenever you want. You can look through the notes that you've written down in the key idea boxes, the ones that you've highlighted, the ones that were shown in red on the videos. You can have a go at the questions in the video again if you want to. You can have a go at more of the slot questions that were listed on Show My Homework next to the video. You can look in your STB, all the information you might need is in there. And you can look in your revision guide if you've got one. Or finally, if all that fails, you can ask your teacher. Now, if it's a simple question, you might be able to email them now. If it's something a little bit more complicated, you can wait till we get back to school and you can make an appointment, go and see them after school or break time and lunchtime just to go through it. Anyway, we've made it to the end of this unit. Well done, everybody. That's all, folks.